have this system of equations, and for those 8 of you who were absent yesterday, this would be like a mini lesson for you. The problem is that there's too many variables, right? In order to solve for a variable, you need one equation with one variable. But we've got 3 equations in 3. So our goal is to eliminate one to get 2 equations with 2 variables. Never mind what I just said. I don't even like what I just said. Let me start over. Our goal, I don't even like, never mind. My mind keeps like skipping 2 steps ahead, and I don't want to confuse you if you were absent yesterday. What we're going to do is we're going to pick 2 equations and eliminate one variable. And then we're going to pick a different 2 and eliminate that same variable. That will give us a system with 2 variables, and we'll do elimination one more time. So we're doing elimination a lot. I'm going to start with the first 2. It does not matter which variable you try to eliminate. If I'm going with the first 2, what do you think I'm going to try to eliminate? Which do you think I like? I like the y's, right? Because their signs are already opposite. So what I'll do, in order, I really, really want a 2 right here. So it cancels with that y above. So I've got to multiply everything here by 2. So I'm going to do row 1 plus 2 row 2. And plenty of you eliminated x, and that's fine. Okay? As long as your math is good, you'll always get to the exact same place. So x plus 2y minus 4z equals 7. And then 2 times everything in row 2 is 6x minus 2y plus 12z equals negative 14. When you add those, the y cancels out, which is exactly what I was going for, giving me 7x plus 8z equals negative 7. Okay. We've eliminated the y, and we're just going to put that there. We're just going to hold it because it doesn't, see, I still have these 2 variables, so this isn't exactly my ending point because I can't solve yet. What I need is another equation with only these 2 variables. So I have to do this process one more time with 2 different of the original equations. So I already used the first 2. I need to eliminate y again. I can either use the first and third or the second and third. It doesn't matter, but I'm going to do the second and third. Okay. So in order, so this was my heart work here, and this is my star work here. So if I'm going to be working with these 2 equations, I really want a 3 in front of that y, so I have to multiply everything there by 3. Okay, so 3 times row 2 plus row 3. Oh my gosh, okay. That's 9x minus 3y plus 18z equals negative 21. And then row 3. Those cancel. I've got 11x plus 17z equals negative 11. So now that I have those 2 equations with those 2 variables, what do I do with them? Eliminate again, right? The whole thing all over again. So coming over here, these are my 2 equations. It does not matter if you eliminate x or z, but I like x. And the reason is just because finding multiples of 11 and 7 for my brain feels easier than finding multiples of 8 and 17. Although either way, if you could always just multiply them by the opposite number, and that would work every time as well. So I'm going to multiply this row by negative 11, which means I have to multiply this row by what? Positive 7, right? Because I'm trying to eliminate the x's. So that is negative 77x minus 88z equals positive 77. And then the second row gives me positive 77x. 10 times 7 is 70 plus 49, 119. Okay. And if you were feeling like really sad about all the numbers, look, they cancel out very nicely all of a sudden here. It's like Merry Christmas. and that's 0, 2. And then this is negative 31. So z equals 0. And that's a whole lot of work to only have 1/3 of our answer, right? But the rest of the work's easier, because this is where we begin just back substitution. We just substitute it backwards and then backwards one more time. And so when I say substitute it backwards the first time, what I mean is into one of these equations from this step right here. Okay, thank you. So I mean one of these equations. Jenny, this is great. So which one do you want? First one, second one? First one? First one? All right, so I'm going to put 0 in for z right here. So 7x plus 8 times 0 equals negative 7. Oh my goodness. That's gone. Bye, see you tomorrow. X equals negative 1, which is great. So we substituted it back one level. Now we have to go back all the way to the beginning level, right? And pick one of those original equations. Which one do you want? Which of the original equations do you like? Yeah, me too. So the first one is x plus 2y minus 4z equals 7. We now know x and z. So x is negative 1 plus 2 times y stays y because I don't know what it is, right? Minus 4 times z, which is 0, which is 7. The 0 part cancels out. Add the 1 to both sides. Divide by 2. I've been mildly whining through the whole problem. I apologize. That's unprofessional. But why would, this is a whole lot of beautiful work, but why would I still give partial credit the way it's finished out? Got to put it in an ordered triple, right? Have to write it as a point. Not the order you solved, right, but in alphabetical order. So x goes first, which is negative 1. Y is second, and z is last. There we go. You have the rest of class to work on your homework. The key is in the back. You may have your music. Does anybody need this up anymore? I got it. Do I want you to bother me at my desk if you have questions? Yes. Also, probably going to have a skill check on this tomorrow. Okay? Just so you know.